Great. So I will go ahead and get started here. I think I have to, yes, there we go. So I am here at my home studio in Trout Lake, Washington. I live at the base of this volcano that's part of the Cascade Range in the Pacific Northwest. That is Mount Adams. And here are some of the fruits from that forest when I go out foraging in my backyard. And so I kind of took a whole journey into getting into the myco world and the natural dye world. I've been fascinated with fungi ever since I was a young kid. I grew up here in this area, and I actually got to visit up until I was about 10, Mount St. Helens. And I don't know how many of you know about Mount St. Helens, but she is the lovely mountain that blew her top. Technically, she blew out her side, but then blew out her top. But she erupted in 1980. And up until that time, I would spend lots of time in her forests and was always fascinated with the mushrooms, and lived down in the Bay Area and had a group of friends that were into fungi. And so it was kind of always part of my life, but I was focused on other things and didn't really dive into that world until I had a pivot from my career doing interactive media design for museums and cultural institutions. So I was out, on this trail, and it was like the yellow brick road of just everything was fruiting. And I thought, now is the time. I need to learn. And I would collect them, bring them into my studio. I would start to study them, learn them, draw them, go out. I joined my local mycological society, the Oregon Mycological Society, and I would go out on forays and really immerse myself. I took identification courses with our group here and all sorts of things. And that then led me to this idea that I had been working with textiles and so forth, and quilting really kind of as a hobby, as a break from the work I was doing like on the computer. So it was more tactile. And I was kind of wanting to switch that practice up and start to work with my own natural dyed materials and my own design patterns and so forth, rather than purchasing, the pre-made kind of beautiful fabrics that are out there. And I first took an indigo class and knew that, there were natural colorants, but I had no idea if mushrooms made color. So after I joined the Mycological Society, I thought, do mushrooms make color? And sure enough, they do. And I will talk a little bit about Miriam Rice and her work and how that important that's been to me. But these are some of the early works that I was doing. And then what I learned is there's a whole long history of using fungi for colorants and for dyes. And it's a lot longer than we previously knew. And that is because of the research of Dominique Cardone, who is like a textile archaeologist. And she published a lot of this work in her book, Natural Dyes, Sources, Traditions, Technology, and Science. And she was finding this common element that was being referenced in the Middle Ages in Italian manuscripts and Dutch manuscripts and French manuscripts. And this reference was popo or opopo. And what that did is that translated to agarico. And agarico, as we know, kind of throughout the taxonomy, the history of the taxonomical work that was being done by Fries, a lot of things were referred to as agaricus or agarico. So that was kind of the first clue that these researchers had, Dominique and her team, of, wait, that's referencing mushrooms. And the more that they dug into it, the more they learned that polypores had a long history of being used and referenced back in time for colorants, whether that was kind of yellows, purples, oranges, those sorts of things, some reds, violets, that just depend. And here I have on the screen Larsifomus officinalis, which we commonly refer to as agaricon. And agaricon was the common element that was used to get that crimson red that we know from the time of the Renaissance. That red was that they could get came from this insect Kermes, but that brilliant crimson color was because of the addition and use of this mushroom. So together, this insect and this fungi bringing to life this very famous, the Italian crimson red. So that's pretty amazing. They were also able to look back through these manuscripts and understand that the use of the polypores for colorants was not just in Europe, but it was also in North Africa, Central Asia, and even Northwest North America, which happens to be where I live. And we have a very special mushroom here, the Echinodontium tinctorium, the paint fungus. This was used for the aesthetic and symbolic red paint that indigenous communities in our areas would use. So here are some of the colorants from that fungi, both dyes and pigments with different treatments. And the illustrations here are by Yuli Gates, who I'll talk about a little bit more. But this mushroom not only contains colorant, Native Americans would use this to help heal insect bites, also protect their skin from sunburns, and also reduce the chance of snow blindness. So a lot of times we're finding these fungi that have colorants also have incredibly important other medicinal characteristics or ecological, those sorts of things, where the colorant happens to be often the secondary metabolite that is produced. So, these are a couple examples. Other polypores that were used, the tinder polypore or the hoof fungus, that was used throughout time, as well as the mulberry polypore. So these mushrooms, like the tinder fungus, that has that inner amadou velvet that has a long history in Transylvania of being used to make the hats, the amadou hats. It was also a fungi that Otzi, the Iceman, was carrying it because it's known as the tinder fungus. So being able to start fires. So there's this amazing, history. These mushrooms were also being traded along the Silk Route. And so not only were they being traded for their colorants, but also that knowledge was being passed along there. And often in these kind of oasis, that's where the mushrooms were fruiting and growing. And that tended to be where the different stops were along the Silk Route, where they could, have shade, water, and so forth. So a long, amazing, lovely history. And that brings us to the contemporary movement. And the contemporary movement was created and founded by Miriam Rice with Dorothy Beebe in the late 60s. And a lot of the history that I just talked about was not known at this point in time. So for Miriam, she was teaching art classes to young kids in Mendocino and was invited to go out on a mushroom foray, which, piqued her interest. And she thought, she'd head on out, and she found this bright yellow mushroom, the sulfur tuff. And luckily for all of us, that sulfur tuff created a buttery yellow, and that sent Miriam down the rabbit hole. And she then dedicated her life and her work for experimenting with mushrooms for color. These are 2 books here. You can see her early one, Mushrooms for Color, that she wrote, and then Mushrooms for Dyes, Paper, Pigments, and Mycosticks, which is available today. And it's that book that I found online It was distributed through Fungi Perfecti. I was able to get that book and learn from it and taught myself. And then being part of the Oregon Mycological Society, they had a group that were dedicated to dyeing because a member in our group, Maggie Rogers, had learned from Miriam and brought that back. And so there was a whole group of people that were continuing this tradition, and Ellen Birnbaum had been spearheading that up. So spearheading that up, sorry. And so I got connected with this group and learned from Ellen and went from there. Another book I have up here is Arlene and Alan Bassett's book, The Rainbow Beneath My Feet, which is also available as a great field guide. So you can learn more about Miriam's work, the International Dye Mushroom Institute that her daughter Felicia still runs today, at mushroomsforcolor.com. So here is the Hyphiloma fasciculare that is the mushroom that Miriam found, and you can see the colors that it created. So obviously, you know, Miriam's instincts were right. This bright yellow mushroom did indeed have pigment in it. This is also a great mushroom if you find them on night walks with your UV, they will fluoresce. And it's also one of the identification characteristics that can help you ID it compared to other lookalikes. So it's a great mushroom. It's a guild mushroom that I'll talk about here in a minute. So I have a background, sorry, my throat's a little scratchy. I have a background in education, teaching higher education to graduate students who are getting their Masters of Fine Arts. And I had been teaching workshops at my studio and other locations. These are some of the very first workshops with the mushroom color charts. So these were the makings of these color charts back in 2018. And then teaching classes, you could see in through the pandemic and into the future. So that's kind of my background of how I got into it. And then as Angel mentioned, I also have a flower farm where I grow fresh cut color. So I grow a lot of plants for color as well as, you know, specialty cut flowers for bouquets. In my local community have a CSA, but I'm a regenerative no-till farmer. So fungi plays a big role in how I am farming and working with my environment. I follow a lot of the Korean natural farming where I'm making all my own inputs, my microorganism soils, all my own fertilizers, and really working with that kind of microbial fungal world and fermenting things and so forth, and bringing that into my farming practices. These are some of the different dyes that I harvest and dry and package and sell. And then I use these in my work as well as in my own studio practice. I bring the dyes and colorants into my practice. So here you can see some pictures of me working in the studio. These are specifically all myco mushroom fungi dyed pieces that I was working on for a show. But here is a most recent show I had here in Portland at a gallery where I found one giant whopping Phaeolus Schweinetzii, and that's the dyer's polypore. And it was so huge and massive that everything I created in this show came from that single mushroom. And I'll talk a little bit more about dyer's polypore, but if you're able to find that specimen in its fresh kind of first year of growth, it is packed full of pigments. So I dyed these 9 14-foot tree totem panels. I created a whole 4 different textiles, then which everything was dyed, the thread, the fiber, so forth, and created those works, as well as turned all of my dye baths into what we call lake pigments. And these are the photographic studies through that process, and then transforming them into watercolor and oil-based paints for these prints, these mono prints. So all of that leads to a project that I decided to create during the pandemic. I came up with this idea for the mushroom color atlas in January of 2021. I was spending time kind of thinking about my intentions for the year and how I wanted to spend my time and what kind of educational outreach that I could provide. I had just retired from teaching full-time at the end of 2020, and the Mushroom Color Atlas was a great opportunity for me to bring together my love of working with fungi for color, as well as my previous career working on interpretive interactive media, and then in my interest in education. So for those of you that aren't familiar, I'll bring up the Mushroom Color Atlas, but this is available online, and it's currently has 825 colorants in it. I can scale these colors down to scroll through them. As you roll over the different colors, you can learn what fungi they are and go click on them. And once you click on them, hopefully it's going to work here for me. My internet can be very slow where I live. You get this record. Here I clicked on the Phelodon niger, so learning about that, seeing the different dyes here, that's that grid of 6, or sorry, of 9. The different fibers and the mordants that are being used, and then the grid of 6 is showing the different pigment, which is created through the lake making process. I'll chat about that. And applying different modifiers to get these different colors. And then I've got little batch notes for each of them. And then I have the preparation for these colorants and kind of how I worked with them and the variables to kind of get these repeated results. Other fungi, I'm looking at them in different ways. So this is the Cortinarius sanguineus, where I was looking at it with alkaline or a base pH compared to a neutral and the different color ranges that you can get there. In the process section, I have information that walks through and documents how to do this and how to get started. And then in the post sections, I have different articles and things that I've been working on and so forth. So that is let's see if I can go back. Hopefully everyone was able to see the Mushroom Color Atlas. So now I'm back to the keynote. So I talked about my former career. I worked with museums and cultural institutions to bring like collections and access to information to life for educational purposes. So I have a love of that, and I had an amazing opportunity to collaborate with my husband. He and I founded our design studio, and his name's Brad Johnson, and he helped work on the visual design. So this is a little background where I was creating user experience diagrams of what that experience was going to be for the website, how people could interact with it and use it as a reference and resource. And then also playing, Brad was looking at the visual design and the typography. And I knew immediately that it was really important that the colors be the primary focus, but the mushrooms had to be present. And so there had to be this relationship, but I didn't want to bring in mushrooms full of color because that would distract from the colors the mushrooms actually created. So I had an idea to do this kind of woodcut or lino cut, black and white, really illustrated images of the mushrooms to support the colors that they had. So I went on to Instagram and kind of researched and looked for different artists that were specifically doing this woodblock lino cut style, and then hopefully with the benefit that they were working with fungi and mushrooms. And through that process, I found Julie Gates, who is an incredibly talented illustrator living in the UK. And the piece there on the left of the edible fungi, that is what I saw on her Instagram post. And I reached out to her and we met over Zoom, and we hit it off immediately and knew we were going to work really well together. And Yuli at the time was a nurse working in the healthcare field, and it was the pandemic. And she said she couldn't think of a better project to do, because when she had her breaks, she could go and draw and work on mushrooms, and that it was really, those saving moments of being able to illustrate the fungi kingdom and that relationship she has with it. So it was really great. The other circle of images are dye mushrooms that Yuli illustrated. And then also the programming of this. I love to work in databases, and I'm kind of a really geeky, nerdy librarian and archivist at heart, and love keeping track of data. And so a friend that I worked with over many years throughout my career, Danny Rosenberg, I was talking to him, and he helped create the back-end system that I could work with to populate everything I was creating, and the front end of how that could work. So between Brad, Yuli, and Danny and myself, we created this mushroom color atlas. I started working on it in earnest in March of 2021 and launched it in October of that year. And these are some photos of me working in the studio. I actually was working on the painting swatches here, but had also done all the fabric swatches. So that led to this incredible opportunity to create a book. Chronicle Books reached out to me to do this. And I thought, real quick, before I jump into the book and where that has gone, if anyone has any questions, I'm happy to answer that. Let's see, someone's asked if I will be going to the folk school again. And yes, I will be there. I'm going to be there in August of 2025. So this coming year, I'll be there, and I'm going to be co-teaching with my mentor, Julie Fitzhugh, and we're going to have a great time working with natural colors and mushroom colors. Julie is a mentor. When I was teaching in higher education, she ran the fibers department at the Oregon College of Art and Craft, one of the schools I taught at, and started a natural dye study group for some of us. And that, when I bought Miriam's book and was trying to learn, and I was in this study group, I was the crazy lady that brought these weird mushrooms in and trying to learn how to dye from them and work with them and see all the different results we got. So Julie's a good friend and a great mentor. So we're super excited to be teaching together.
Yes,
okay.
There's a few other questions. Yeah, there's a few other in the chat. Nancy, and you may have to clarify a little bit, but she asked, can polypore, and I don't know if she meant the one that we were showing at the time, the dyer's polypore, be used to reach, after it has reached its prime condition, can it still be used?
So what I've found, as well as other mushroom dyers, so there are a lot of people out doing incredible work with mushroom dyes. There's a great community online that Alyssa Allen runs. She has a tremendous amount of experience. It's on Facebook, the Mushroom and Lichen Dyers United. And so if you go to that group, and then the work that I've done, we have found that if you find a dyer's polypore from the previous season, the pigments contained in there are very few, if any. If you find an old polypore that's from a previous season, you might be able to get some browns from them if you make it an alkaline dye bath, so higher pH, but that's hit or miss. We have found that time and time again, you're not able to get any of those goldeny, yellowy oranges or greens from them. So you do have to find them in the first season that they're growing. And the way to tell, one of the best ways to know is if, and I'll show an example of that, if the fungi, the Dyer's polypore has this kind of whitish, yellowish rim around it, then you know it's in peak season. You'll be able to see the yellow golden pigments, and when you turn it over, you'll be able to see the greenish pigments in it visually. And then you know you've got a great specimen. Sometimes you'll find them young and they'll be like a golden little squishy bread loaf sitting there. And they have pigment in them, but often I mark those and I come back later. I kind of watch them over a few weeks and let them mature because they're going to grow a lot bigger and they're going to be full of a lot more pigment. So.
Another person, Carrie asks, how would people dehydrate mushrooms a long time ago? Perhaps the sun, she asks, and then
yeah, probably just out in their condition that they were in the warmth, and letting them, setting them out, maybe not in direct sunlight per se, but in warm conditions. Also bringing them, indoors. So if you're finding them in like the wetter time of year and you've got a warmer environment that you've created, just bringing them in and just letting them slowly dry over time. And once you do dehydrate them or freeze them, they will keep for extended periods of time. So most likely building up caches, just letting them naturally dry, and then, in the spring and summer when it warmed up, bringing them out and drying them out. So.
Aaron G asks, and feel free, do you want to come on unmute and ask your question? I think this one's a fun one and very species specific.
Oh, that's a very good question, Aaron. So Aaron is asking about Sarcodon imbricatus, which is the, or imbricatus, sorry, however you put that, which is the shingled hedgehog. And she is wondering if there's any way to get the same colors from Sarcodon squamosus. Okay, so first of all, between these two species, identification can be challenging. So a lot of times people don't notice the subtleties and the ways in which to identify the difference between the two because they look so similar. In our area, the Sarcodon imbricatus, we refer to as the hawkswing, and it is a good edible that people enjoy eating. When I take people out on forages, I often say when we find these, if they aren't attuned to, it's basically, for me, the way to tell the difference is the patterning on the top of the fungi and how that looks. There is, for someone like me, I can spot the difference immediately, but for a lot of people, it's hard. So what we do is we look at the habitat we're in and the trees that are growing where these fungi are growing. Both of them have a mycorrhizal relationship with specific trees. In my area, Sarcodon imbricatus is with spruce, and Sarcodon squamosus is with pines. And I think that carries through into a lot of other regions. Sarcodon imbricatus has proven time and time and time again to not have any pigment compounds in them. And we cannot squeeze color out of them to save our life. We might get a slight beigey color. And it's Sarcodon squamosus that is the dyer. And it creates beautiful purples and bluey green colors. And it contains a really unique pigment compound, a terphenyl quinone or terphenyl quinone, however you want to pronounce that. And that pigment compound is found nowhere else in nature except in fungi. So it's very exciting for me. So hopefully that helps clarify the question. There's been studies and papers produced on this because it has proved very confusing throughout time. I've done the test too myself and documented those. And I was thinking, you know, I should put the Sarcodon imbricatus up online on the Mushroom Color Atlas. And then people can see. It's just no color or a slight beige color. So
nice. All right. I think it's a good point to jump
colors
back in.
of light fastness. Yes, I'm going to talk about that as we just get further into it when I've got some colors up on screen. And then, yeah, mordants play a really important role, and I will talk about those. So the fixatives, I don't necessarily work with fixatives per se, but I work with modifiers to adjust the pH balance. And for fungi, those tend to matter more so than other producers of natural colorants, like flowers and things like that. For a lot of the fungi, if you don't adjust the dye bath, you won't get that color because the fungi are more particular and they need certain environments to coax the color out. And that's where sometimes people can think that working with mushrooms for color is maybe a little more complicated or advanced. And that's because you do need to modify the pH of the dye baths if you want to achieve certain colors. That's not true for all mushrooms. Some work neutral just fine. But I found really easy ways to do it, just using some household vinegar as your acid and some soda ash as your alkali. Historically, people used a lot of ammonia for alkali, which works great. I always love to say, you know, there's 1,000,001 ways to do all this. And there's really no right way or wrong way. There's your way and what works best for you. And ammonia works great. I've just found that as I work outside, but when I have the heated fumes of the ammonia, it gives me just a little bit of a headache. So I opted for something different. But yeah, ammonia works great. So dye took some of the recycled blue over that lovely green. Oh, cool. Great. Well, maybe you can share that later, Fazia. That would be great if you want to come on. Okay. Yes, mordants, confusing. I will get to them and we'll talk about them. I did cover a lot of that in my book. And so, yes. Okay. So on to the book. Wow. That was a good segue. So, mushroomcoloratlas.com exists online, and there is now a book. Both are companions to one another. I was approached by Chronicle Books to create this book because they had seen my work. I was in a group show called the Wild Pigment Project that Tilka Elkins ran for years, and it was in a gallery in Santa Fe. And that gallery happened to be hosting an opening event for a symposium called the Santa Fe Review, which brings a lot of photographers and editors and writers together. And one of the editors from Chronicle Books was there, Natalie, and saw my work and thought this has to be a book. And so I was completely blown away to get that invitation. And I immediately thought, a book? I don't know anything about books. I mean, I'm a consumer of books and I love them, but I didn't know anything about how to create one. So I spent a month in January of 2022, January of 2023, thinking about this. And this is kind of what I came up with. I thought, you know, if I'm going to create a book, I really want it to be an educational resource. I want it to be interactive. It needs to have companion content that isn't on the website and vice versa, so that they can work really well together into the future. And I didn't know anything about a book proposal, but I ended up researching that and putting together a book proposal that I presented back to them to get their input and feedback. And So you can see I had the book in these sections of the colors and the mushrooms, and then how to work the process into that. And ultimately through that, I ended up with 3 sections instead of 2. But I started similar to how I worked with the Mushroom Color Atlas. I started to think, what is the experience of this book? How could the chapters be organized? So this is kind of how I went through that, and then started to visually think how to bring it to life. So these were kind of the visual mood boards of what I had available in terms of content and how it could like work together. And then looking at the mushroom section, and again, spending a lot of time thinking about how the mushrooms were represented in this section. Mushroom photography, as many of you probably know, is an incredible art form in and of itself. And I am not a mushroom photographer. I mean, I love taking pictures of them, but you know, when you see the incredible work that Alan Rockefeller and, you know, other people are doing out there, he's just to name one, it's amazing. And it's also a lot of work to find these mushrooms at different times in their life, and different, you know, different stages and different views of them and so forth. And especially for dye fungi, that's really important. So I started to think about botanical illustrations and how those had always been incredibly helpful to isolate different views, you know, cutaways, different stages of life. And so I thought, I wonder if Yuli has ever done any botanical illustrations. And I was looking at different, you know, botanical illustrators, and then looking, you know, within that, people who were doing botanical mushroom illustrations. And you can see I threw one in to this approach for the book. And I just thought, well, I'm going to reach out to Yuli. I know she primarily probably works with lino cut wood block. And she said, you won't believe this. This group that she volunteers for, this I'm forgetting, par fungi. Anyways, it's an activist volunteer group advocating for the use of psilocybins for medicinal purposes in the UK. She said, I just did 2 for the group, and I can't believe this. I'm so excited. I'm going to do a test dye mushroom for you, and I'm going to send the illustrations that she had done. And I knew the minute I opened up my email and saw them, I was like, this is amazing. So Yuli created all of the illustrations that you see in the book, and worked extensively with me to create these for the mushroom section. This is Yuli sent me pictures of her. She drew them all by hand with colored pencil. And then she brought them into the computer well, sorry, not the computer, her iPad, and used Procreate, and would apply all of the more detailed line work and kind of ink work to those. So we spent, you know, a good 9-10 months working together to create and bring to life these colorful illustrations that would show the key characteristics of the fungi, but also for identification purposes, be accurate to help people identify these mushrooms that have colored. And here we are, the team. The Chronicle Books team was amazing. That's Yuli and I together. And then the team of Natalie, Winnie, and Kristen. And yeah, so together, along with other people that I worked with, you know, John and Charlie and a group of people, Jack and Annie, but we created this book. But here is a subgroup of that team that worked closely together for many months. So I love this quote from Johannes Itten about color, and that whole, you know, we've got the fungi kingdom and we've got the kingdom of color. And to me, each of them is a universe in and of itself, but this idea of that power of them to contain it all within that one mushroom and the possibilities that are in that. It's very exciting. So I'm going to walk through some colors and some mushrooms, and I will chat about some of these questions that people brought up. And if I forget them, just interrupt me as we go. So that glorious red, I mean, who could imagine that the fungi kingdom could deliver all those shades of red? You know, we tend to find them from a lot of gilled mushrooms. And the way I like to help people who are beginners or novices get into the fungi kingdom, because it can become very complex with the taxonomy and with the kind of keys of keying out a fungi, can get a little overwhelming. So one of the main ways to just as a starting point to head you into the right direction is to look underneath that cap. And that is what we call the spore-bearing surface of the hymenium. And the hymenium can come in many different ways. It can be gilled, it can be a sponge, it can have tubes or pores, it can have teeth, it can be a sac contained with all kinds of spores. And so that is a really great starting point that can help get you in the right direction. You know, one of the things with fungi and the fungi kingdom is it's a relatively young and new kingdom. It was founded and created in 1969. And there is so much that we need to learn and are learning that it's a really exciting field because it's constantly changing and evolving based on new science. And, you know, the microscopy that had been done for years with the microscopes and now being able to send specimens out for DNA sequencing and bringing all of that together. The taxonomy, basically the genus and the species, when you get down into the Latin names of these, they're often changing. So, you know, when I started working on this just over a decade ago, a lot of the fungi, they have been reclassified, they have been swapped, they have been changed, they've been moved around, and that's because science is teaching us so much more. And one of those genus, the Cortinarius genus, which has the gilled, the little gills under its cap, it has been split because it is one of the largest genus. So there are sub-genuses. For us that are interested in colorants from Cortinarius, we're specifically looking at the Dermosinae sub-genus. And then within that, we're learning more and more. For example, in the area where I live, we thought we had about 13 different Cortinarius Dermosinae species. And now that hundreds or even thousands of specimens have been sent off for DNA, it's come back that we most likely have up to 50 different species. But the problem has become how to identify those correctly and know what exact species they are. So now we're often thinking of these Cortinarius Dermosinae as the species complex, because there's so much to learn still about these. But this particular one is the Cortinarius neosanguineus that creates these amazing reds. They're often tiny. You can see my hand is holding them. They're very, you know, small compared to some of these massive Dyer's polypore and some of these tooth fungi and things that can grow really large. And in this grid that you see here, this is the fibers. So the top row is wool, the middle is silk, and the bottom is a cellulose fiber, which is linen. And linen is flax. So another cellulose fiber is cotton or bamboo or hemp. But in this case, I used linen. And then the mordants, those go across the top. So the iron mordant is on the left, working with stannous chloride down the center, and alum is on the right. So you can see in this grid by using different fiber types and just 3 different mordant types, I can get an array of 9 different colors. Some can look similar, but they're different. They're unique in and of themselves. And so this idea of mordanting, before 1854, every color that you would encounter at that point in time, or if you've encountered anything historically that you've seen that was created before 1854, it was all from natural colorants. And if we were using natural colorants on fiber, we had to find a way to affix that colorant, to bind it to the fiber. And that is the discovery that they made, because these natural materials, their purpose was not to produce color. We just happened to find they had that capability, right? That's a mushroom's purpose is not really for color by any means. It's a secondary. When we think of different plants or flowers, that's not their primary purpose. So they didn't bind fiber unless we treated that fiber with what we call a mordant, which is the Latin term to bind or to bite, mordere. So that's where that concept comes from. And within the world of mordants, it is unbelievable. Everything there are so many things there. Minerals that can be used. There are metallic salts. There are natural plants. There are leaves. There are fungi. There are, oak galls. There's tannins. There's so many things that can be used as a mordant to pre-treat your fiber so that your mushroom will bind. In this case, the mushroom colorant will bind to it. Now, there are some fungi that have some incredible superpowers where they have probably, most likely, I don't know because the science hasn't been done, but they probably contain some type of tannin or something where they can bind to a fiber without a mordant. And one of those is the Dyer's polypore, Phaeolus schweinitziii. And that is a great beginner dye mushroom, because you can get that yellow color without mordanting your fiber. It might fade a little quicker or slightly fade and then hit a stable color versus if you use a mordant. But that's really the concepts of mordants. And I don't know, do people have questions about that? I could talk about it forever, but I don't want to bore the people who don't have an interest. But if anyone has a quick question, I'm happy to answer it, because I'm going to jump to pigments next. So hopefully I answered the question back. Confused me. There's lots of them. Knowing where to get them from, which ones to use. Yeah. Okay. So hopefully I covered that. I didn't cover everything, but there's, you go down these rabbit holes and you learn these nuances of working with pre-treating your fiber with mordants and how that is going to impact the resulting color. So, okay. No questions. I'm going to jump to, oh, I see, hold on, a question. Oh, okay. Dyer's polypore does grow in Texas. Angel can speak to that. She's heading east to East Texas, and they find them there. So we were just chatting earlier. Okay, so now you can see the pigments that this Cortinarius neosanguineus produces. It will actually produce a red pigment. Now, the pigment in the upper left corner, I don't know if you can see my pointer, that is the base pigment that I get from the lake making process. The other pigments that you see, I have applied a modifier when I am making that paint and I'm doing that watercolor. And you can see that using different things like citric acid here, this orange one, or soda ash, or copper or iron, are changing, they are modifying, they are changing the color of that pigment. So you can have a base pigment, but you can work with these modifiers during the process of either mulling and making your paints, or in the act of actually painting, using them as washes and things. So that's how I got those 6 different colors from the pigments, was I was just modifying them, which is really, really, really fun and yields all kinds of different results. So pigments, when you're making any kind of paint or ink, you need what's called a binder. And don't confuse a binder with a mordant. They're very different, but they are in essence kind of doing the exact same thing, in the sense that when we think about the mordant, was used so that the colorant could bite or bind to the fiber. A binder is doing the same thing, so that when you put your paint down or your ink on whatever substrate, it's actually going to bind to it over time. And there are a lot of different binders that you can use to ultimately create a huge array of paints and inks. You know, I like to, in work that I do, I work a lot with soy milk as a binder. I work with gum arabic for watercolor, or gum tragacanth for printing on fiber. If you want to make, I make oil paints, so I'm working with an oil base. You can make tempera. You could even make acrylic paint. I don't really know why you want to do that after going to all this effort to work with a natural colorant, but you can. So you can work in any type of binder. And the really cool, amazing thing that the fungi kingdom has to offer us is that the jelly fungi that are considered asciomyces, or they're in the asciomycota, they work as a binder. So I will often find those jelly fungi. So it could be the cat's tongue or witch's butter. And I will just basically cook them down, put them in with some water and get a gelatinous consistency. I'll strain out the mushrooms, and that can be used as a binder. So even the fungi kingdom, you can make mushroom paint that's 100% mushroom. So it's really exciting and fun. Okay. Am I missing any questions? Ooh, is someone saying that they can dye with cordyceps? I have to play with that. I've never heard of that. I'm not sure that they can, but you never know. You got to experiment and learn, and everything's always changing. Okay, so advancing on, these kind of orangish colors, we can get some amazing. Oh, what I forgot to mention with the with the red colorants, I wanted to touch on the light fastness and color fastness. So the reds colorants are anthraquinones, and that is a very light fast and color fast pigment compound. That pigment compound can be found in other natural sources, like madder. The red from madder uses an anthraquinone, and so forth. The pigment compounds in the mushrooms are not exactly the same pigment compound as in madder, but in terms of, they're all an anthraquinone. And what's important about that, just 1 second, sorry, is that anthocyanins, which are a pigment compound found in a lot of natural materials that can create great colors, those can sometimes shift or change over time, or fade at a slightly higher rate. Now, all colors, whether they're synthetic or not, are going to eventually fade over time. But mushrooms in general, and this is something I really want to spend more time with, I want to find an institution that has a testing machine where you expose the fiber to light for certain periods of time and at certain light levels to get a more detailed light fastness and color fastness report and documentation. But we know Miriam did some work. She published it. She sent it to the USDA. I have only seen what she published and not in the, any files that came back or might be in the archive. But the report is that they did prove to be much more light fast and color fast than other natural materials. So we know a lot of them do really well. But these oranges and yellows, those are the colorants that can be challenging for light. Yellow in general can tend to fade more over time, but you can find yellows that are incredibly strong, like the plant weld or like the polypore. So a polypore here, instead of having that gilled surface on the hymeneum, it's going to have this sponge surface. And here we've got phaeolus, and phaeolus creates a very stable and light fast yellow if used with a mordant. It will also create that color without a mordant, but it will fade ever so slightly over time. So the mordants help. And you can also, soy is a great UV protectant. So I apply that to all of my textile work that I'm doing in my studio and so forth. But so here you have phaeolus, and I mentioned earlier that kind of perfect moment in which to harvest. And this is an example of that specimen with that whitish cream. And you can see the range of colors that phaeolus gives us. And here's a little detail where you can kind of see that sponge-like. So these are polypores. Polypores can grow on the sides of trees. They can grow at the base of them. Phaeolus is known as a butt rot. So a saprobe who's responsible for decomposition of the remaining trees and stumps. And then the pigments that you can get. So here we get into the yellows. And this range of yellows, you can get a lot of great yellows from boletes. And so boletes, again, under that cap, that they look different than what we've talked about with the gild or the polypores. They have these tubes or pores in them. So this is the zircomelus, and you can see that color in there, and then look at the yellows that it produces. This is an incredibly mature, worm-ridden, completely rotted out, flipped over. I didn't even harvest this specimen because it was just a big ooey gooey mess, but I loved the color of it. Here's younger ones that I'm holding in my hand. So those are tiny little cute babies, but they can grow much larger. And what's interesting to compare is that the pigments from boletes in general, but then looking at this one, can often be very challenging to work with. What I've found is those pores, those tubes that it has, they're very, very hard to strain out. And you can tend to get a little bit of mush into your pigment, and they don't make super strong pigment colorants. I'm still playing more and more to see if there's a way to get a more vibrant pigment color from a bolete, but I haven't been that successful with it. There might be ways to work with extracting through solvents like alcohol and stuff that might prove better, but I haven't been successful with that either. Oh, now we're headed into some of my favorite, the greens, the blues, and the purples. So as I mentioned earlier, the greens, the blues, and the purple are coming from the terphenol quinones. Those are those unique pigment compounds not found anywhere else in nature except in mushrooms. I love the odds and ends section of every little guide. And here I created the odds and ends section in the book because I had these key fungi that I wanted to include, but I didn't have enough of their types to put into the book because I had to look at page count and all that stuff. So this is one of my favorite mushrooms. It's commonly known as a blue chanterelle. It's the polyozellis, and this particular species is the Atrolojulinus. And it is just absolutely lovely. To me, they look like bouquets of flowers on the forest floor. Look very similar to like a black trumpet, but it's a fruiting larger cluster. It's all held together, and I just love them, and they're so easy to work with. This is a great example of a species or a genus species of fungi that you don't need to modify the pH of the dye bath. You can work with it neutral. Now, Phaeolus, you don't necessarily need to modify the dye bath. You will get the yellow colorant, but if you do make Phaeolus a little more acidic, you're going to get a range of colors that tend to be a little more intense. So again, you can see that range of colorants across the fiber types and the mordants, and then the pigments. And, I just love combining this with that copper acetate and getting that incredibly vibrant blue-green. So a little false gild, and then we get into the blues, and the blues come from one of my favorite categories of fungi, the tooth fungi. So again, when we think about that hymenium, that underside of the cap, that spore-bearing surface where the mushrooms are releasing their spores, these have teeth or spines, and they are just stunning. When we were talking about the Sarcodon imbricatus versus Sarcodon squamosus, those are tooth fungi. And so here you can see the different drawings of these. And this is one that I love that produces just beautiful shades of blues and teals. This is Hydnellum cerulleum. And, often people will ask me, does the color of the mushroom mean that's the color that it produces? And the answer on a general scale is no, because everyone can see the Amanita muscaria, the fly agaric with that red-orange cap, and that mushroom doesn't have any pigment compounds in it. It's primarily white. It doesn't have any colorant in it. So the answer to that question in general is no. But as you start to work, and as you've seen in this presentation, with dye fungi, they have colorant in them, and that colorant often is what you can coax out of it. So when you start to get that discerning eye, you can see the color, and that can inform when and how you want to harvest these. I tend to like to wait for things to be a little more mature, middle-aged, not past their prime, but not super young, because they're going to be full of more pigment, and you can then kind of nurture and care for that habitat and that environment where you're finding these, go back to them, watch them over time. And then when you're harvesting, I really like to think of my own ethical practice with harvesting, and you really have to think about what is important to you. There's lots of debates on harvesting fungi, and I don't want to get caught into those debates, because yes, you can pick every mushroom. Yes, you can pluck every mushroom. All the the studies have been done and the reports have been made. But I like to think that I am just going to take the handful that might be the most mature. So with Hydnellum cerulleum, I often find them growing along, not literally on the roots, but visually they're connected. They have a mycorrhizal relationship with the trees. And as they fruit above ground, you can see them kind of in this line, and they're moving through, and you can visually see, wow, this must be where the roots of the trees are growing underground. I will just pick a few there. I want to leave these mushrooms behind for biodiversity. There are a lot of other insects and creatures and microorganisms that depend on these. They create habitats, they're a source of food for different mammals, not just us. And I also want to leave some there so that they can go through this spore bearing process, release their spores, decompose back into there to make that habitat healthier over time. And so that's why I tend to think about what I'm harvesting and when I'm harvesting it. And I'm always like with the Cerealium, I want every patch where I come across this, I want it to continue to be healthy. They're very important for the health of the forests and those relationships with those trees. So I really want to wait until I can get a few of the more mature, larger ones. Here's the pigments, so you can see how those are very different. And then we get to the purples. Purple throughout time has been a highly coveted color that was reserved for, the wealthy, the royal, the elite, etc., because it was very rare. But we do have fungi, and there are some lichens that make incredible purples as well. This is looking at a bolete. And I love to put up Tapenella atromentosa, which is the center image with that dark kind of velvety foot. This fungi is a bolete, but look what it has under its cap. It has gills. So this is something we consider a gilled bolete, because most boletes are like these other drawings that have these pores and tubes in them. So, like I said, it's a good starting point for novices and beginners to think about what is that cap to kind of categorically organize things. But the fungi kingdom will always prove you wrong. There is never a foolproof rule. There's always these exceptions. And that's, it's fascinating learning more about them and realizing that this mushroom that we think is a gilled mushroom is actually closer related and is a bolete. So very exciting things. Here it is, the purple colorant that you can get, on wool. So a lot of people will say, oh, I really want that, smoky purpley color, but I can't get it. Or it's not working on cellulose fibers. So fungi must not work with cellulose fibers, which isn't true. People may not like the colors that you get on cellulose fibers, but they work. But if you really want that purple, you need to use alum and you need to use wool to get it. So that's the hope that the Mushroom Color Atlas, if someone has found some of these or is curious or wants a certain color, they can kind of hone in and learn, oh, that's the direction I need to head to work with this. And here's its pigment compounds. So, how I talked about the boletes, it's challenging to get, a more intense colorant. And that proved true with Tapenella. We're getting these kind of lightish, yellowish, brownish colors. Okay, so before we head into a process, I'm going to open it up for questions. Do people want to come on and have questions, or I'll look and see the chat?
So Sago asks if your book addresses mushroom dyes that fluoresce under UV.
It doesn't address those. So for example, if I dye something with phaeolus, so the base of this scarf is phaeolus that was then eco-printed. If I bring my UV light out in a darker setting, you'll see it fluoresce. So that's how the fluorescence kind of carries through with the colorants. But there's a handful in here that do that, and there's one the Omphallotus olivescens, and that is actually bioluminescent. So it will bioluminesce in the dark naturally. So it doesn't fluoresce. You don't need a UV light. But that doesn't transfer to the dyes themselves. So I have some things, you know, that I've dyed with Omphallotus, and if you will not bioluminesce at night if you're wearing that garment. And then because it doesn't fluoresce, you don't get anything with UV. So, what other questions here? I'm scrolling back up through to see if I missed anything. Yes, so hopefully I did answer yes. You can use pigments for watercolor and any other kind of paint or ink that you want to create. You know, people will be like Felicia Rice, who is Miriam's daughter. She's a printmaker, book creator, and she will create printing inks that she's using. So she's getting them super fine to work with the printing process. And that has to do with how you're screening and straining your lakes. So we'll talk about that in a second. Let's see, what else? Oh, orange, favorite. Okay, Erin asked another great question. Do any of these mushrooms not lake well? And yes, there are some that can prove to be challenging. You have to babysit them a lot, or you can decide to make an ink out of them by concentrating them down and getting an ink. One that is very challenging for me, I have gotten it to work, but I elect not to do it anymore, is laking Pysolithus oeris, which is the dyer's puffball. It's also known as dead man's foot, or my favorite, dog turd. Those can prove incredibly challenging to lake because those are puffballs. And so you've really got to strain them out really, really, really well. And when you're going through the laking process of letting them like precipitate so that you're separating the pigment from the liquid, the supernatant, that process, you know, most of the time you can start to see it happen within the hour of that separation. And maybe if you leave it for a day, it'll fully separate. But with Pysolithus, man, I have had to leave it for weeks and months to get that separation to occur. And because that mushroom doesn't mind high temperatures, I tend to just go ahead and concentrate it down. And I never really get that powdered form from it because I haven't laked it, and I keep it in an ink form. And I really love that. So that's an example of one. Boletes are also challenging to lake, but if you have some patience and some time, you can do them. I've got some here on my table that I've laked that I've left, you know, go for, I don't know now, maybe they're end of September. So, yeah, so the pigments, so talking about the light fastness applies to the pigments as well. So if you're making paints, some of them can shift. For example, they may slightly, sorry, shift is not the right word. They may slightly fade. So that sulfur tuff that Miriam Rice found that created that really buttery yellow, as both a dye and a pigment, it can slightly fade to become even lighter over time versus going with the yellow from Phaeolus. That's not the case. I really would love to collaborate with a chemist and start to break down and understand the makeup of all of these pigment compounds from a scientific point of view to understand what's going on. And I think as we turn towards the fungi kingdom for colorants more and more at scale, I think that work's going to start to get done, and we'll start to understand why, and then we'll know better which ones are going to maybe, you know, fade a little bit more over time versus the others that are not. Oh, great. That's a good idea. The American Institute for Conservation. I can look at that. Oh, how do I decide about eating or dying? Okay, that's a good one. So the blue chanterelle, which why it's named the blue chanterelle, it is in no way related to the Cantarellus genus. That is an edible mushroom. And I personally don't enjoy eating it. It's got a little too much of a woody texture for me, and it's just not my favorite, and it tastes a little bland. Now, I do have friends who enjoy eating it, but I don't, and so I die with it. And I love the play on the dying, making color, versus dying, you know, moving into another world, passing away. But maybe I just don't like blue chanterelles because I know, to me, the color they make is so beautiful and I'm in love with it, that maybe there's something going on with me that's like, oh, I don't like this, I want to die with it, make color. But you know, another great one, like porcinis. Porcinis are delicious edibles. I love porcinis, are one of my absolute favorites. And if you've ever found a blown out porcini, where you look under the cap and that spore bearing surface, those pores are just that incredible kind of yellowy olive green, and they are huge and massive. It's in that, and only in that part of that mushroom, where the color exists. If you slice through a porcini, it's white everywhere else. There's no pigment compound except in that the pores in the tubes. So I will take those off and use them for dye. Now, most of the time, if I find a mushroom that's great, or sorry, if I find a porcini that's great for color, it's way past its prime for eating. It's usually riddled, you know, with maggots and worms and other things. And so if it's an ooey gooey mess like that one I showed you, I just leave it and let it, you know, take on its life cycle and still continue to be a habitat for other things in the forest, or food or whatever. If it's blown out, not ooey gooey, sometimes I will just take that layer and toss the rest of the mushroom, you know, back into its environment so it can just decompose down into it, because I'm not going to eat it. So those little buttons, porcini buttons that we all love to eat, if you look at that spore bearing surface, there's no colorant in those. Often they haven't even fully formed and developed. So I'm going to eat every porcini that I find that's in that state, and then everyone that's blown out, I'm going to use it for dye. Let's see. Do I try to pass on the spores? Yes, so that is a great question. So a lot of times when I'm looking at what I'm going to harvest for color, I'm looking at, like, has it released its spores? And often you can see that on the forest floor. You can see that spore print or that release, or you can see it on the mushroom itself and tune into it and understand, like, oh yeah, this has already dispersed its spores. It's no problem. If I'm picking somewhere I'm not sure, I'm often walking with like a mesh bag or a basket. And as I'm moving through, you know, people talk about how the spores can release and bounce along as you go and so forth. If I'm taking some that I know haven't released their spores, I'm leaving plenty behind so that they can release their spores. So, where are the portraits on? Yeah, okay, so I think I talked about this. Yeah, they do if we've got a mushroom that UV fluoresces and are working with that dye and pigment, it's a high percentage chance that it will, like Phaeolus does, and some of the others as well. So yeah, you can do that, and that's fun. No, most pigments are not coming from the spore-bearing surface. The spore-bearing surface is an identifier, and it is a form of pigments for certain types of mushrooms, certain genuses, but no. A lot of the tooth fungi, for example, that's not the case at all. All tooth fungi are brown spored. And actually, when you're making dye baths, you can sometimes think like, oh, I've got a failure on my hand. I'm not getting blues or greens or whatever. It all looks brown. And that's because those brown spores of that fungi are coloring it. And as soon as you wash it out, you will see your color. And in those tooth fungi, it's all the way through the mushroom. When you cut those open, you can see the pigment compounds are down in them. That's true for Phaeolus and others. So no, that's not the main case. Amanda Boulder Colors. Oh, yes. I love what Amanda's creating. She's a great person for everyone to reach out to. She does small batch natural colors that she's taking through the lake making process. You can use mushrooms in multiple ways. You can dehydrate them. I tend to do that as my primary way for long term. And you can also freeze them. I just don't have as much freezer space. Or you can work with them fresh. And then in the Mushroom Color Atlas, I've shown some of the differences that you may encounter depending on how you decide to work. Okay, any other questions? I'm going to jump into the process here of working with those mushrooms. So you're out foraging, you're preparing them in advance. And I touched on the different ways quickly, but I have more in-depth information about that. And I am doing this to create for my mushroom dyed textile pieces, and then other things I'm finding and making are for educational workshops. So these are a few examples of my pieces. The one on the left that's blue is from the Hidnellum Fusco Indicum. And then the one on the right is Cortinarius. It's Cinnamommosis or Subcrucifolius. We're not exactly sure on the taxonomy there. So the equipment, you really don't need much. You do want to make sure what you're using is not your kitchen equipment that you would, make your pasta or your soup with. And the reason for that is just primarily that if you were to ingest a mushroom that wasn't, say, a good edible, but could make you sick or has some toxins in it, you want to make sure that you're not, doing a bad job cleaning that pot and then go take it in and make your pasta. That would be a problem. So these few things, often you can source them at secondhand stores, thrift shops, Goodwills. It's just a few basic pieces of equipment, some pots and jars and so forth. You do need to consider if you're going to pre-treat your fabric for the dyes, if you get a mordant. Two really simple ones are aluminum potassium sulfate. That's alum that we use for pickling. So you can find that in a grocery store, or you can make an iron mordant, just with some rusty nails and some vinegar, and you can do that. And it's very simple. So it's not a big barrier to entry to get involved and start experimenting. It's super simple. These are just a range of all the different dyes of playing with those fungi and what you can get from that. And then for the paint making, the lake making process is slightly confusing. It's called a lake pigment because we are taking a soluble dye bath. So you can make a dye bath, meaning you're coaxing the colors out of the mushrooms. That's what the dye bath is. It's full of that colorant. You can decide to dye something in it, or you can decide to turn it into an insoluble pigment. And that insoluble pigment becomes that powdered pigment here in this picture that you can then use to make any kinds of paints or inks. The lake making process is actually very simple. You're adding basically a substrate for those color molecules to attach onto, and then you're adding a precipitant. And that precipitant is gathering those molecules together, making them heavy so that they separate from the liquid. And then you filter them out and you're left with that powder pigment. So that's the lake making process. The French were really curious about the color purple to get a purple pigment. As we talked about, purple was a highly coveted color, and they were using lac, an insect, to get a purple that they could dye fiber with. And they thought, how could we get this to be a paint, like a pigment that we could use? And so they invented this process, came up with this way to do this, you know, years and years and years ago, hundreds and hundreds of years ago. And it had been unknown for a long period of time. And in 2016, I think it was 2016, a group of scholars, conservators, and textile paint conservators at museums went back through and documented it and explained it so that people like us could all start doing that process. And because they were using this insect lac, an English person translated it to lake. And that's why we call them lake pigments, which is really, you know, kind of confusing because we think of a lake as a body of water. But you can get a whole range of pigment colors from doing that process. And it's a great way for mushrooms because as you're working with natural dyes, one of the things I think is important to pay attention to is the temperature of the dye bath. As you're extracting that colorant, how hot is that water getting? Sometimes you can zap or brown out the color if it gets too hot. And that's because those pigment compounds start to break down and deteriorate. So not every mushroom is a great candidate for other processes like concentrating them down, you know, bringing them to a boil, and over time concentrating them down will sometimes not work. Some are a little more finicky and difficult to do through solvents like alcohols. But some can prove difficult, like the Pisolithus and some of the boletes for making lakes. But on the whole, it's been a great solution. So questions about that. Now, before I switch to the future of what is happening, because it's super exciting. Fungi are being used to create color at scale, and they have the potential to change a lot of things. So let's see. Any dye mushrooms? Okay, so I am not aware of anyone like cultivating, and this is a good segue into what I want to talk about next. Cultivating dye fungi like the way we might, you know, I could cultivate some shiitakes, you know, in some logs on my property, or I could do some lion's mane in my house, you know, with a little grow kit. I am not aware of that happening at that level. It could be, and I just don't know about it. A lot of the dye fungi have mycorrhizal relationships, which make it harder to cultivate them because they're depending on a very nuanced relationship for the fungi to grow and then to fruit. Others are saprobes, so they are decomposers, and those have the best, I think, potential for getting into kind of that small batch home growing solution. So we could start to grow some of them. I do know that Jimena has grown some dye mushrooms. I'm forgetting if it's the Tremides. I can't remember what she did, but she did have success, but no one is making these kinds of kits and stuff that I know. And Angel might remember my memories.
Yeah, that was right. The Tremides
sanguinis. Sanguinis, okay.
Yeah, and that one also has a like really deep orange mycelium. So there's another artist, Chris Ritson, that does a lot of really cool molds, like sculptures.
Yep.
That one's a fun one.
And okay, so I'm gonna hold that, make sure I didn't forget anything. Yeah. Okay. Do you see ours? Okay. The artist conch, I have never been able to successfully get a great color from that. I tried and I just got a beigey color. But I think it might be interesting to keep trying and seeing if it can produce maybe, I don't know, some more yellowy orange. But anyways, okay. So this is a good segue talking about growing. Sorry, my throat got very, here, I'll have one of my cough drops. I was on an airplane and managed to catch a cold. Hopefully this isn't too annoying for everyone. Just a second. I don't want to cough in everyone's ears. And I don't know what happened to my controller. So, okay, the future. So the answer is fungi is being grown at scale for industry for color. Hold on just a second. Okay, I'm back. Hopefully my throat is cleared. It is happening. Scientists are doing this in various degrees and stages across the country. They're doing it in lab settings. I love Jeffers' work at Microbiome World. You know, he's incredibly excited with fungi as nature's new color palette. And this is some of his work here showing that palette range. And scientists are evaluating colorants from mushrooms for the food. Oh, just a second. Okay, that I guess is the sign telling me I have to stop talking so much, but I get very excited about this. So growing color from fungi for the food industry, cosmetic, as well as fashion. And it is happening. Chromalogics in Denmark is growing fungi at scale in bioreactors, creating a red colorant for food. And they're using that same technology and applying it for colorant for fiber to get a red fungi color. There are scientists in Finland. Prod is looking at that Cortinarius mushroom that created that amazing red that I showed you. He's looking at a different species. It's a Cortinarius sanguineus that we don't, or I'm not aware of us having it here in the States at this point in time. He mapped the entire genome. So this is a fungi that is mycorrhizal. He mapped the genome. He figured out what that fungi needed to grow. He has cultivated it, cultured it, and is growing it. He ended up feeding it a certain type of bees. He can now harvest it for color doing it in large bioreactors and setting it up for scale at industry for fiber. And then PIA in Germany is actually growing the Ionotus hispidus for the mycelium and getting the colorant from the mycelium. So like Angel just said, with the Trametes sanguineus, oh no, my voice is really failing. Okay. She is growing this, so she's not fruiting this fungus. She's just working with the mycelium. And that's like what MycoWorks is doing, working with the mycelium for leather. So she's working at it just for the color. And then Sari Robinson at Oregon State University near me works a lot with spalting fungi and has scaled up their lab within the School of Forestry to basically extract all of these colorants using different solvents to basically look at the larger, paint and stain industry. So I won't get into lots of things about spalting fungi, but colorants can come from them. And then ColorFix in the UK is working with different fungi and enzymes for fiber as well. So the thing that's really exciting to me is we have a whole movement of looking at sustainable regenerative materials for the fashion industry and starting to really, now my eyes are watering. I'm really falling apart. Sorry, everyone. Really looking at that fashion movement and transforming it, because we all know there's a whole variety of issues in terms of the carbon emissions and polluting the waters and so forth. And the cool thing is that movement's moving forward. We're paying attention now to fibers, and we're thinking about synthetics and the toxins and everything. But it's seldom that we think about where our color comes from, but that is now finally starting to change because of this work being done at these different institutions, and fungi is playing a central role in it. So it's very exciting to me. And I will end on that and open up to any other questions, since I don't know, look like I'm crying or something crazy is going on with me. I'm not sure.
Yeah, thanks for hanging in there with us.
Oh yeah, sorry, my
and I hope you get feeling better. It's always.
Oh, I'm fine. It's just some dry throat,
Yeah. Yeah. So, are there any other questions? I did notice a few that have gone by. Someone had asked about applying these natural dyes to surfaces that are not fibers. So things like a plastic, or even like a canvas for like, or other paper for like watercolor.
So for the dyes, so when you think about dyeing, like, yeah, definitely you can use papers, different things. You're going to need to immerse. So it's just like an immersion dye technique. So whatever you have has to be able to become soluble. Now, when we look at fiber, which is more what I know about than other substrates, fungi will dye some synthetic fibers, which is just kind of crazy to think about. So nylon, it tends to dye nylon really, really well, but polyesters, it doesn't tend to bind to and to dye. I don't know the exact reason for that, but what's interesting is Sari's work with the spalting fungi. Those solvents, or sorry, those pigments tend to dye synthetic fibers like polyester, much better than natural fibers. So you kind of have to think about and do some tests like, what is the substrate you're trying to dye, and see how well. Now with the papers, I've played with it a bit, but I'm not an expert, but I have found that I do the similar treatment that I do to the fibers, where I mordant the paper. And then I get some better results than if I didn't mordant the paper, or I should say I get results that I'm happier with. And so you do take it through a similar process. I don't know that fungi could actually dye plastic. I've never tested it, and maybe someone out there's doing it, and I'd love to chat with them. I don't know. You know, I know there's fungi that will eat and decompose plastic. It'd be kind of interesting to learn more about those, see if they have any pigment compounds that we could then extract and turn around to adhere to plastic. But, you know, for me, it's all about moving away from synthetics and thinking about the environment and, you know, some of the climate issues we're facing and how we can navigate through that. And so my preference is just to try to use less synthetic as possible.
So I think now would be a good time to do the giveaway. And I used a random number generator to pick a winner tonight of the Mushroom Color Atlas. And what I'll need you to do is just email me your mailing address. And I chose the name, and it ended up being 2 people that were signed in together, Kylie and Jonathan.
Oh, great.
Yeah, so Kylie and Jonathan, if you can mail me I'll DM you the email address.
And then we'll get a book out to you.
Yeah.
And I'm excited to hear what you think.
Yes.
Well, thank you, everyone. This was great and fun seeing you, Fatsia. Let's see, a preferred vendor. You know, my preference is that you work with whoever you prefer, but I'm always rooting for the indie bookstores. So if you have a local bookstore, or go to bookshop.org to search and find one that you could support. If you're able to do that, I think that's really fantastic and wonderful, and it really helps those small businesses. So that would be my general preference, is if you can do that. But.
And do you know if it is at our local Book People? That's one of the big booksellers here.
I do not know, but we could look them up and see. You could just you're in Austin, right? Yeah, I don't know. Let's see, they don't have a quick search. So I'm sorry. I don't know.
Yeah, I can call them and find out too, and maybe share that on social media.
Oh, here, wait, here's a shop button. I was looking for a search thing. A lot of the independent bookstores use bookshop.org as their distributor, like for online, so that they don't have to go like create their own distribution system. Let's see, I'm typing it in now. Yep, they have it. It says availability on our shelves now. So they have it at the store, and then it looks like you can also buy it online from them if you wanted to have it sent to you.
Great.
Cool.
Yay, this has been so great. So much
Thank
to
you
learn.
so much, you guys. Yeah, and I hope you know, fungi lead you to some wild and colorful places. So
yes, I'm hoping to find some things this weekend in East Texas.
Yeah, keep me posted, Angel. I'm so excited. And yeah, you guys, I would love to get down to your area. You've got a few bucket list mushrooms that I'd love to
that hisser, that Texas star.
Well, I've just, every time I see pictures of it, I'm like, oh, look at that. Oh.
Yeah, we're just starting to see them again. But
Good.
one question that I actually had was,
Yeah.
so can you mix pigments? Is that something that you can do to get some of the coloration?
Yes, you can definitely. And so when you're making your
Mhm,
paint, you can mix them all in together. You can
mhm,
also mix them while you're doing the painting process. So if you had kept them
mhm.
separate, but it's really fun to mix them and see what you get. Sometimes you want to be careful because you can just get brown,
Muddy.
if
Yeah.
you, yeah, exactly. It can get muddy. You can do the same thing with dyeing. Um, you can over dye and mix mushrooms and do different things. And that's something we're going to be doing for the week when we're at the folk school, is doing a lot of over dyeing and documenting that. So it's going to be fun.
Great. Well, if we don't have any other questions, we'll say goodnight.
Yeah. Well,
And
thank you. And thanks for
yeah.
persevering my throat wanting to break down and whatever, the final moment. Thanks so much. This is great, you guys.
It was really great. Thanks again. And
Yeah,
good
have a
night,
good evening.
everyone.
Take care. Bye-bye.
Bye bye.